Hello everyone, this is Abhishek Srivastav, and in this video I'm going to demonstrate the working of my project which I have built in a 5-day Google Generative AI program powered by Kaggle, right? So now in this project, I've tried to build an application which will ease out the human efforts for reading and understanding the research paper, and this will be beneficial especially for the people who are doing their masters, PhDs, or whosoever is involved in the research work involving the reading of numerous number of research paper. I myself have been doing some of the projects lately under professor, and there also when the time comes to read the research paper, then don't ask us. We also lose sweat, but this application which is built by me will be easing out the effort which will be earlier made by the human manually. So, right. So first of all, let's go through our project step by step. The name of the project is AI powered research assistant. As the name suggests, I hope the purpose of this project is now clear to you, right? So now talking about the summary, like I have employed the usage of generative AI and tools for building this project. With respect to the models LLM which I have used and other features of this project, I'll be covering all that stuff later on, right? So I'll go through this notebook step by step so that you all can understand it well, right? So some of the core innovation, or I would say the key features of this project which I have implemented are: the first of all, it is the contextual conversation memory, right? I've built a feature which will be allowing to chat with the LLM by giving input as the research paper, and the LLM will be storing the history of the conversation between the user and the model, so that if in future the user wants to ask any question related to the past, then the LLM can it can answer it successfully, right? The other two exciting features are: first of all, there is an accessible audio summary playback, and the other is intelligent mind map generation. These two features have been inspired by the notebook LM tool which we have been using in our 5-day Google Generative AI course for reading and understanding the white papers which were given to us on a daily basis, right? Talking about the generative AI proficiency which has been employed in this project, first of all, there has been an advanced document understanding, right? The other is sophisticated few shot prompting. Talking about few shot prompting, it basically is to give some examples or illustrations initially to the LLM, and then in return giving a question by the user to the LLM and expecting the response in the same format or manner which was which was the format of the previous examples given by the user, right? So this is basically the procedure of few shot prompting, right? Again, I've employed the uses of extensive long context window for better semanticity and better response generation, right? And then there has been implementation of the RAG pipeline for Q&A feature with the model. Semantic embeddings have been employed for converting our text into vectors. Output parsers have been generated to beautify and clean the data generated by the LLM. Intelligent agents and conversation memory feature have also been employed for performing Q&A, for querying by with the LLM model based on the paper which we have given as the input. And multimodal output have been integrated in this project, in which the first one was audio generation, and talking about the visual, I have right now only implemented the mind map generation, right? Okay, so talking about the technologies which I have used, first of all, I have used LangChain as a framework for chaining LLM based operation. ChromaDB I have employed for a for using it as a vector database. We can use other databases, vector databases also, such as Fires, but for now on, I have stick to ChromaDB, right? For Google Generative AI package have been used for answering queries by the user by employing the usage of LLM model. Llama index package is majorly used for implementing RAG pipeline and data pre-processing, right? And I'll tell you why I have used specifically Llama index, right? Google text to speech feature has been used for the audio generation. PyPDF has been used for PDF parsing, and PyVis has been used for the mind map generation, right? Okay, so now first of all, going through first of all, let me give you all a brief about the workflow of my project. Here, the user will be uploading the PDFs, and then the text cleaning will be performed, and after extracting the information from the PDFs, then after the cleaning of the text, chunking will be performed to break the large size documents into smaller chunks, right? And then those chunks will be converted into embeddings, vector embeddings will be stored in our Roma vector database, and from where we can retrieve or extract certain relevant vectors for our question and answer session and conversation with our LLM. And then at the end, I've also integrated LLM evaluation. Like this is mainly for the purpose of giving how our LLM model is performing, right? Okay, so first of all, here I have installed all the necessary packages which are going to be used in our project, right? uh, then after that, I've imported all those packages, right? And like if I just give a brief through, some of them are like uh, talking about the Google Generative AI, Google Text to Speech, IPython.display. From this package library, we have imported two functions, audio and markdown. For mind maps, we have imported GraphViz, collections and all, PyViz, and all these stuffs like sklearn, matrix, cosine similarity, and PDF reader, LangChain, tools and packages, Llama index, libraries, all these have been imported, right? Now after that, first of all, this command is used to clear any pre-existing information if anything is there in the output directory of a notebook, right? Then okay, then we have set up the API key. Like as I have used the Google AI Studio API key for accessing my Gemini model, right? And then after that, here I have stored it in my environment, right? Named by Google API key. Then comes the process of data cleaning, right? So in data cleaning, some of the key features which I want you all to see is targeted noise reduction, right? So now, first of all, I would like to draw your attention to this, that the data cleaning which I have employed is not just any ordinary data cleaning. It is specifically designed for tools like this AI research assistant, because what happens now, if I show you all a sample research, like this is a research paper, a survey of optical navigation, right? So in this, what happens in this type of research paper, there are many things to keep in mind while parsing the text carefully, right? So first of all, there are these section names of the section, right? Introduction and all. Then in every page there are some footers and headers which we need to ignore while extracting our text, right? Because they have no such special use case. Then obviously when we are passing our text, then we need to ensure that our images, the text in our images are not being extracted at all, right? And then after that all these hyperlinks have been also removed, right? So that our text is parsed clearly and carefully as well. And then again, there are many tables like in these type of research paper. Like here also there are tables and text is present in those tables. So we need to also take care of that, right? Then after that, if I show you, there are many mathematical expression and like numbers given to those expressions and the figure caption as well. So all these things have to be taken care of while parsing out the text, right? So here in my tool, I have first of all incorporated three major features. First of all, there is targeted noise reduction, where this clean text function is majorly going beyond generic text cleaning and specifically removing common research paper elements like the headers, author, survey titles, copyright notices, figure table caption, and citation blocks, right? So this focused approach aims to preserve the core content more effectively than broad cleaning, right? Okay. Then the other is semantic section awareness. So this feature attempts to identify and tag text section like the section which I've shown you all, like the abstracts, introduction, conclusions, and then approach, all that stuff, right? And then also we have adaptive document handling, where like we have used the sentence splitter thing which is used to like chunk our text into like smaller pieces from the large documents, and also ensuring that only the relevant information is captured at all after the text being extracted from the PDF, raw PDF, right? So here is the code. Like here we have used the created the code to remove the headers and footers, and here to remove the figure and table captions and all. uh, we have also used to normalize the white space after parsing the text, right? So after building all this, now let me show you what are the final results, right? So here I have used the like wrote the PDF path where my our PDF is stored, and then I have read that PDF using 5 PDFs PDF reader. Then I have stored all the pages of that PDF along with the page number, and then I have applied the cleaning and processing function, right? So after that, if I show you the result of this, let's say these were the result of my raw text from my raw document, right here. So after this is the original text, right? Pure, no clean text, unclean text. So here many errors are there. Like this is one of the header. This is figure caption. These are the citations, right? All that stuff. But after cleaning, like here documents which we get after cleaning or pre-processing, like if I show you the here the text charts from RGB images, and if I show you the exact same text here, and here yeah, so here it is RGB images or one of the used in each simulator, right? Then there is backslash n. Then here it is the citation number 89 after HM3D. And if we see after this, the citation number have been removed and the backslash n feature also, right? So all that stuff have been removed, right? And the text is has been cleaned at a much better extent as compared to the usual techniques of the text papers, right? After the text cleaning has been done, now comes the most important step, that is creation of the RAG pipeline. RAG stands for Retrieval-Augmented Generation. So here, first of all, for that we have created functions for creating, generating the vector embeddings. Vector embeddings, we have used the Gemini embedding 001 model, right? And so here we have created a wrapper function for it, and then After that, we have created our embedding model, uh, right? Yeah, so we have created our embedding model, and then we are creating our Chroma database, and then we have defined our retriever, which will be retrieving the relevant or semantic vectors from our vector database optimally while while we try to query from our LLM, right? Now, like comes the step of querying with the LLM, and here first of all we have seen all the available models available in the Google Generative AI library. So these are the list of model. Amongst these, I have used the Gemini 1.5 Flash LLM, large language model, right? And then here is our prompt. You are a helpful research assistant. Answer the user's question using the context below, right? So here the context which we'll be going to get will be from the retriever.info statement, right? So here comes the role of retriever for getting the context related to the based on the query which we are giving to the LLM, right? So here we are generating the response based on the prompt which we are giving, and in return we are getting back the response and the context related to that, right? So here, let's say I have given a prompt of explain me the SPL evaluation matrix, right? So here, if we see, this is the necessary prompt, which this is the necessary response which the large language model has given in return to the query. And if I show you for verification purpose only, so here it has said that SPL will be 0 when S is 0, otherwise SPL is this, larger SPL means higher efficiency and all. So all that stuff, and if I show you all where this information is written, this is the part. SPL is a metric to evaluate efficiency of agent navigation, and here this is the required text which the model has returned. If S is 1, the agent finds, otherwise S is 0 and all that stuff. So this ultimately proves that the response is being generated at a much better extent, right? Now coming to the output parser, right? So as you can see, right, as you can see that if I try to show you all, uh, yeah, if I try to show you all the answer which we got in return from based on the query from the large language model, it is like this. Like it has some backslash feature and the inverted commas and all that stuff, right? And many a times when it was using, let's say, any board character, then it was also getting some uh, strings like double asterisk, right? And so we don't want all this stuff, right? So we have designed an output parser which will refine the output generated by the LLM, and after like cleaning the output, we'll be getting the text like this, right? See, it is much cleaner now, right? Okay, so this was the purpose of output parser. Then coming to the feature of text to speech, I've used the Google text to speech library to convert the clean output which we have got from the output parser to convert into audio. And if I show you, then it is like
SPL, success weighted by path length, is an evaluation metric for efficiency in navigation tasks. When there is no success, S equals 0. SPL.
yeah, so this was just an example of the audio sample, right? Coming to the conversation memory feature, I have leveraged the conversation retrieval chain from line chain um, library, and also have used the chat Google Generative AI LLM large language model, right, to like set up all this stuff. So here I have like initialized my large language model Gemini 1.5 Flash with a temperature of 0.5.3, right? And I've given the argument of converting the system messages to human as true, right? Then I have initialized the question answer chain, conversation retrieval chain dot from LLM, and here I have then initialized the chat history as null, right? So then after the first query, like let's say what is the main contribution of the paper, and then some response we'll be getting, and then we'll be appending that response in our chat history. Then a follow-up question regarding that for the information which the large language model has responded in the past. Based on that, we have tried to query a certain question, and then again we are asking a new question. Then again we have asked the author level info, and then at last for test purposes we have again asked a question based on the authors, which try to relate and get information from the past conversation, right? So now, like, if I want to tell you all that how it is like getting information, so basically what it is doing, as far as I am seeing, that the chat history, which is being stored step by step as the conversation is proceeding, all the chats are being compiled in our retriever, so that whenever any question is being asked from the previous conversation, the most similar chat will be already present in our retriever, so that can be extracted and the statement can be the query can be answered well enough by the LLM based on the previous responses, right? So like, now talking about the LLM evaluation, like here I've tried to evaluate LLM with respect to three dimensions, right? So first of all, dimension was keyword overlap. The second dimension was the LLM based self-evaluation which the Gemini model does, and the third dimension was semantic similarities, right? So for keyword overlap, it is like it is fine that if we want some specific keywords to be present in our response, then we can here give those keywords as the list, and then in the model the response given by the model can be evaluated. Then the self evaluation which we have used is like I have given the prompt based on three parameters like groundedness, relevance, and correctness of the response. Groundedness refers to is the answer generated based on the given context or not. Relevance is does it address the question being asked, and correctness is how factual and accurate is the information given by the LLM model, right? So the scores which these three parameters will be in the range of 1 to 5, right? So now like after generating a report, like right, first of all, let's say I have passed the context, like talking about context. What is this? Context is basically, I would say this, the context related to the query which the LLM model used while answering this query, right? So I have passed this context text through my output parser to get a cleaner context, and then evaluated the response and generated a report, right? And then when I printed it, then the semantic similarity score of the generated output is 0.7717, and other scores are as follow, right? So semantic similarity score is actually being calculated by using the I would say cosine similarity function, which we have imported from the scikit-learn package, right? Now coming to dynamic few shot prompting, uh, why I have shown this, like many people must be thinking that the regular RAG chat session or the conversational buffer chat history feature should be enough, but dynamic few shot prompting is necessary because whenever we are wanting the response from the LLM model in a specific manner, Then what do? We try to give it some examples with some sample queries with their solution, and then by giving a test query, we are expecting the response of that query in a similar format based on what the previous response to the sample queries were, right? So here, talking about the code, I have build up this a few short prompt code, uh, and like it basically what does it does whenever we pass any abstract like this, so based on this it retrieves some of the previous uh, context, right, some of the previous context from our vector database, and taking those as the sample queries, it generates us a summary, right? And then on the basis of that summary, the model is expected to return a response for the actual input abstract which we have given, right? So here, let's say I've given a query abstract of modular method usually consists of a mapping module, policy module, and a path planning module, right? So here, when I have given it, I've also passed the prompt like. Here, you are a research assistant giving an academic abstract generator 3 line summary, right? This is the main prompt. So by this, the model is expected to like generate summary of these two example, and after that, when the test case comes, then it is generating me a 3 line summary based on the query abstract, the input abstract which I have asked, right? So this is just like as I would say amazing as it is. Like it is a very mind-blowing feature in the field of LLMs and generative AI. Right. So coming at last to the two other main feature. First is the mind map generation. Uh, I guess, yeah, okay. This is the last part only. Okay. So this mind map generation here, I have tried to make a mind map or flow chart of the whole some paper information which a large language model has extracted, right? So first of all, for that I have extracted the full context from the vector database which the LLM has. Then I've utilized, and I would say I've utilized the networks function from the Pybase library and the HTML uh, I would say text tag for generating interactive mind maps, right? So after all this, when the final mind map is generated, then it can be seen like this. I'll just show you all. Uh, yeah. So if I open this, yeah. So if you see, then we see that uh, first of all, the first section of this paper is abstract, right? So this is the very first feature, like what are the components or the sub sections which we have to study in the abstract, right? Then there is, let's say, this object goal navigation, and then let's say there is discussion, then let's say there is I would say evaluation matrix section, preliminaries, and all that stuff. So all this is interconnected based on the workflow of the paper, right? And you can also adjust the positions and of the nodes present in this graph just like this. Like, isn't it interesting? Like you can slide all of this to get a clear view, right? And this, right? So this is just, and here we are concluding the presentation of this project. So, like I've tried to build this based on the information I have gathered in this 5 day generative AI course as much as possible. And future improvement obviously involves some feature like collapsible mind maps, just like the notebook LM. Then topic highlighting, which topic is more important, all that stuff. A long-term memory integration can also be done, and also multi PDF interaction can also be integrated in this too, right? So all this, like we can also use the text to image generation feature for getting the summary of the paper in form of images, not in terms of the mind map. And also obviously we can also deploy this project using MLOps also. So all this was all from my side, and let me know like what are all your feedbacks on my project and some scope of improvement which I have to do, or what further we can aim for improvising this into a professional. So that was all from my side. Thank you. Have a good day.